Welcome everyone. I'm excited to be introducing to you today 11 new mechanical knees, which we have recently incorporated into our range due to the acquisition of Medi Prosthetics by Össur. We now have a more complete range of knee solutions for K1 to K4 users, and I'll be taking you through each of these knees today. So I just wanted to start by briefly going over the K-level definitions, as we now have knee solutions for users ranging from low to high activity levels. Your K1 user, they're typical of the household ambulator, using their prostheses for transfers and limited ambulation within the home. We have K2 users who are typical limited community ambulation, looking to traverse low-level environmental barriers such as curbs, stairs and uneven ground. A K3 user, they generally have the ability or the potential for ambulation with a varied cadence, and they may also have vocational or exercise requirements that demand prosthetic use beyond simple locomotion. And then the K4 user is simply someone who exhibits high impact demands of the prostheses, typical of a child, an adult, or an athlete. So this slide is just showing you the complete set of knees we've incorporated into our range. It's worth noting at this point that we still have all of our existing knees, nothing has been replaced or removed. If you start from the left, we have a simple locking knee, the monolock knee, and progressing towards the right, we have the balance knee OFM2, which is a weight-activated friction brake knee, great for interim use and beyond. The OP4 is also a weight-activated friction brake knee, but it incorporates a pneumatic swing phase control. There are polycentric knees with pneumatic options, including the OP5. And then we also have the OH5 and the OH7, which are hydraulic swing phase control knees for more active users. And today we're introducing the Paslow, which is an auto-adaptive pneumatic knee capable of high-speed walking and running. And it's an exciting new product, and I'll go through it in further detail towards the end of the webinar. So I just want to briefly discuss the alignment setup for the knees. For the monocentric knees, it's simply a case of just bisecting the socket at ischial level with the appropriate amount of flexion, and then pass this line 5 to 15 millimeters anterior to the pivot axis of the knee, depending on how stable you require the knee to be for the user, and allow that line to fall through the posterior third of the foot. And then with the polycentric knees, the pivot axis is the most proximal and anterior axis of the knee, and the alignment reference line should pass through the pivot axis and posterior third of the foot. And it's worth noting that the knees do work best when they are upright. The monolock knee is a robust monocentric knee for transfemoral amputees, and it features a single function lever for the user to unlock the knee for sitting. So the knee is recommended purely for use at K1 level, for minimal ambulation, mainly indoors, for users requiring the highest level of safety during stance. So it has a robust locking mechanism, which makes it reliable for user confidence during initial rehabilitation and beyond. It's a nice lightweight but durable design, with a low build height for clients with long residual limbs, and it can be combined nicely with the flexible balance for its cushioning and multi-axial capabilities. The monolock knee has a knee flexion angle of 140 degrees, and it's made for aluminium for a lightweight design, and it's rated to 125 kgs. The balance knee OM8 is a mechanical 4-bar polycentric knee, suitable for transfemoral clients of a lower activity level for your K1 to K2 users. And despite it being small and compact, it's rated to 136 kilos. The OM8 features adjustable geometry with stance release setting, which basically enables a fast and practical setup. The prosthetist can adjust the geometry to allow for an earlier or a later release into stance, depending on the client's needs, and without having to then adjust the alignment position of the knee on the socket. There's also an integrated extension spring, which can be adjusted to optimize extension speed for the user. This spring comes in one strength, however it can be turned clockwise to tighten and increase the extension rate, or turned anti-clockwise to slow down the extension rate. This knee also has a screw, which allows you to adjust the friction axis to help dampen extension if required. To adjust the OM8, The extension spring setting, it just requires turning the spring clockwise if you want to increase the extension assist. For example, if you want to help users with poor voluntary control reach full extension before initial contact. The knee will come with an Allen key, which you can use to adjust the friction of the axis. This screw is found in the posterior of the knee, and by turning it clockwise, the axis friction will increase, and by turning it anti-clockwise, it will decrease the friction, increasing the extension rate of the knee. And then the stance release setting adjusts the geometry of the axis, and this screw is found on the anterior of the knee. You can see on the bottom picture here, by turning the screw clockwise, it will change the geometry, creating a more dynamic gait, as it will release into swing sooner. And you can increase the security for the user if necessary by turning the screw anti-clockwise, creating a later stance release. The balanced knee OM8 has a pyramid top, a maximum flexion angle of 160 degrees, which gives the knee a greater freedom of movement for kneeling and sitting, or getting into a car. And as I mentioned earlier, it's rated to 136 kilos. The balanced knee OFM2 is a single-axis knee joint with a weight-activated braking system, and it also features an optional locking mechanism as well. It's actually a great option for your K1-K2 transfemoral users, including interims, as it's adaptable in terms of allowing the user to walk with a free knee, or utilising the optional lock for additional security in early rehab, or use in prolonged standing. I use this knee a lot in the UK for interim patients, with a view that they would then continue to use it beyond initial rehab, as the lock can be removed by the prosthetist later on if it's no longer required, and the knee can be continued to use as a free swinging knee with a weight-activated brake, making it quite versatile. The weight-activated friction brake can be finely adjusted to suit individual user requirements, and it also features an integrated adjustable extension spring, and it's rated to 125 kilos. The brake sensitivity adjustment is found on the anterior of the knee, and it's easiest to access when the knee is flexed. Look to increase the sensitivity of the brake for users who are not confident walkers or who aren't loading their prostheses fully, and therefore they require increased security and stability during stance. And you can do this by turning the B screw anti-clockwise, therefore increasing the sensitivity of the brake. The extension assist is accessed underneath the knee, labelled E in this photo. It can be turned clockwise to close up the spring and increase the extension assist, or turn anti-clockwise to decrease the extension assist. And another nice feature of this knee is that there's a screw that enables you to adjust play. If you experience any play in the knee after a long term of use, this screw can then be tightened up. It will reduce the play in the knee. It's handy to have because it's something that you can do yourself in the field without needing to send it back for a service. This screw is sensitive, so I do recommend just doing a small adjustment at a time, because if you over tighten it, it can cause excessive swing friction. The balanced knee OFM2 has a dual function lever, which allows the knee to be locked until there is a requirement to unlock the knee. For example, when the user wants to sit down, they just need to pull the lever gently to unlock it. At the same time, the knee can also be used free as a mechanical knee joint if the lever is pulled up completely, disengaging the locking function. And the prosthetist can also deactivate the locking mechanism if the patient doesn't require the locking function anymore. The balanced knee OFM2 also has a pyramid top, and it actually has the lowest build height of this type of knee on the market, and it's rated to 125 kgs. I will now introduce the balanced knee OFM1. It's a mechanical 4-bar knee with the benefit of having a dual function lock in the same way that the OFM2 has, that I've just described, which allows users to lock the knee for safety and early gait training, making it a good choice for interim and definitive prostheses also. The knee is aimed for lower activity levels, K1-K2 users that are home and limited community ambulators. The 4-bar knee provides geometric stability and stance, promoting toe clearance as well from mid-swing shortening to help reduce the risk of stumbling or trips or falls on level and uneven ground. Extension dampening can be adjusted by adjusting the axis friction, and swing phase can be adjusted using the integrated extension spring. So it has a good maximum user weight of 136 kgs, and it comes with a choice of 4 proximal adapters, depending on individual demand. So there's actually 6 knees in the range that you have this choice of 4 proximal adapters. It means that the knee cannot be ordered without an adapter, and the part number for the knee will change depending on which adapter you choose. So I'll just run through the proximal adapter options that you can choose from. The knees in the range where you can choose from proximal adapters are the OFM1, the OP5, the OHP3, the OH5, the OH7, and the PASO. So we have a male pyramid, which allows 5 millimeters of medial, lateral, and anterior posterior shift, as well as 360 degrees of rotation. So it gives you plenty of adjustment for knee rotation, and it also allows you to do some small shift adjustments as well if you need to, once the socket has been laminated. The 3-prong adapter is a good option for users with long residual limbs or who are through knee, as you can keep the build height down. And this also allows 5 mm of shift in the AP and the ML direction, as well as 360 degrees of rotation. The loop adapter is also great for keeping the build height to a minimum. It comes with rotatable discs, which allows you to tilt the socket up to 10 degrees in one direction. So essentially it allows you to adjust adduction, abduction, flexion and extension angles to a small degree once the socket has been laminated. The IKF adapter gives you the option for stance flexion if that's desired. IKF just means initial knee flexion or stance flexion. The adapter has bumpers to provide shock absorption and to replicate the natural action of initial knee flexion during early stance, and facilitates walking on slopes and uneven ground. The front bumper can be changed to different densities depending on the user weight, and there's no possibility of shift or rotation if you're using this adapter, however, so that's just something to bear in mind. Just something at the bottom of the slide here, if you're not a fan of our carbon female bonded pylon, we do now have an aluminium tube with titanium bonded female pyramid, and that's rated to 136 kgs. And that's compatible with all of our knees and feet, and it's worth noting here that all of the integrated products have been tested for compatibility across the board and have been found to be compatible with all our existing products, including no issues with mating to our feet. Back to the OFM1, we have the option to adjust the extension assist in the same way as the previous knees I've just mentioned, and then also we can also adjust the axis friction. The posterior screw can be turned clockwise to increase friction and anti-clockwise to free up extension. The knee also features a dual function lever, allowing the user to have the knee locked manually and locking it in sitting, and it can be kept free, otherwise removed altogether if the patient progresses through rehab and it's found to be no longer necessary. The OFM1 is rated to 136 kgs, has a knee flexion angle of 150 degrees, and as I said before, essentially you can't order this knee without a proximal adapter, so you just need to decide which one's suitable for your client before you order, and the part numbers are up there on the screen. So I'll just introduce you to the OP2 knee. It has a pneumatic polycentric knee, and it's essentially the same as the OM8. However, it has the addition of a pneumatic cylinder for users who do have the capacity to vary their walking speeds. So therefore it's aimed at K2 to K3 transfemoral users. It features full bar geometry, providing stability and stance, mid-spin shortening for toe clearance, and improved safety on level and uneven ground. It also features the same stance release setting as the OM8. It allows you to adjust the geometry of the axis for a quick and easy adjustment in order to provide more stability in stance or a more dynamic transition to swing. The pneumatic cylinder allows you to adjust the resistances to flexion and extension in order to fine-tune the gait for the user and to help eliminate any excessive heel rise or terminal impact. It's also a slim design. The bars have rounded edges, and it does actually help when cosmetically covering the knee. So it's actually a very good option for K2 users who require stability, and they're also concerned about cosmesis. As with the OM8, turning the stance release setting clockwise will provide an earlier stance release and will therefore feel more dynamic for the user. And the flexion and extension settings on the pneumatic valve are set independently from each other. So turning the valve clockwise will increase damping, whilst anti-clockwise will decrease damping. The flexion valve on the pneumatic cylinder can be used to adjust heel rise, and the extension valve adjusts resistances to extension and can be used to modify thermal impact. The OP2 has a the OP2 has a fixed male pyramid and a good maximum knee flexion angle of 160 degrees for ease in sitting, and it's rated to 125 kgs. So moving on to the OP4, the OP4 is basically an OFM2 with a pneumatic cylinder. So it utilises a weight-activated braking mechanism, but with the addition of the pneumatic cylinder for users who are K2 to K3, and they're capable of varying their walking speeds, but still require the stability of a friction brake during stance. The friction brake is finely adjustable, so for a lower K2 user you can make this knee very safe. And it also features the brake play screw as well to reduce play in the knee after a long time of use. It also has a slim design, allowing it to be cosmetically finished quite nicely. As with the balanced knee OFM2, you can adjust the sensitivity of the brake. So turning it clockwise will actually decrease the sensitivity, and turning it anti-clockwise will increase the sensitivity, increasing stability for less confident users who require increased stability in stance. And the pneumatic cylinder is easily adjusted from the posterior, so the flexion valve is found on the lateral side, and that can be adjusted to control swing flexion. Turning it clockwise will increase flexion damping, reducing excessive heel rise, and the extension valve is found on the medial side of the knee, and that's adjusted to help control extension, increasing dampening for users looking to walk faster than just a single walking speed. And then the brake play screw is labelled P on this picture, and that, as I said, can be adjusted to reduce play. And again, this adjustment is sensitive, so just make some small adjustments at a time, so that you don't over tighten it and cause excessive swing friction. The OP4 is rated to 100 kgs. It comes with a fixed male pyramid top and a maximum knee flexion angle of 145 degrees. So the OP5 is a polycentric knee with a pneumatic cylinder for transfemoral and knee disarticulation users in the K2 to K3 range who are capable of varying their walking speeds. So it's a good option for users with low voluntary control, as it has the benefit of 4-bar geometry for stability and stance, and mid-swing shortening for increased safety from tripping or catching the toe. The pneumatic cylinder enables a variable cadence for walking speeds of up to about 4 kilometers an hour. And this knee also has the option of 4 proximal adapters, including the loop adapter if you have a knee disarticulation patient or a user with a long residual limb, or the pyramid adapter with the ability to shift 5 mm in each direction and rotate as well, allowing you to adjust the alignment if necessary, even if the socket is complete. The swing phase control pneumatics is similar with the OP2. You can adjust the resistances to flexion and extension independently to fine-tune gait. The pneumatic adjustments are best reached from the posterior of the knee. And there is a maximum flexion angle of 145 degrees. It's rated to 125 kgs. And the part numbers are there on the screen for the different knee options for the different proximal adapters that you can choose with this knee. The OHP3 is a polycentric knee with a powerful pneumatic cylinder, so this is actually aimed at your higher K2 to K3 users because it's utilising a higher active pneumatic than other knees I've mentioned. It's capable of walking faster than 4 kilometers an hour. It has several features as well that you can use just to fine-tune to the patient's needs. And one of the main features of this knee is that it has closing geometry in the construction of the knee. which means it's inherently more stable and safer than the standard 4-bar design during stance. It ensures stance phase stability from load and response, with a high degree of stability throughout stance phase until weight is applied on the toe in conjunction with a hip flexion moment in order to release the knee. And I'll go into this further in the following slides. The knee comes with 2 wedges called A and B wedges that can be fitted to make the knee more dynamic and release quicker for your more active users, in a similar way to how you can add and remove shims from a total knee. And the OHP3 also comes with the option of 4 proximal adapters. So I'm just going to run through this video. I know that some of these videos will be lagging today, so they will all be available to download when this goes up on the Össur website in the next week. In a standard polycentric knee, basically the instantaneous center of rotation is positioned posterior and proximal at heel strike, and then the knee will then bend when the patient initiates a hip flexion moment. However, with the closing geometry design, the instantaneous center of rotation actually stays behind the load line for a greater period of time, creating enhanced stability. So at initial contact, the instantaneous center of rotation is actually in front and below the ground reaction force, and this means that the knee is inherently stable even if the user creates a hip flexion moment at this point. And at mid-stance, the instantaneous center of the knee is moving through the floor until the front and the rear bars of the knee move into a parallel position. Then the instantaneous center of rotation moves to be proximal and posterior towards terminal stance, and the ground reaction force is therefore still anterior to the instantaneous center of rotation until the toe is loaded and a hip flexion moment is initiated. So I've just broken this down into a few sections just to make it a bit easier to digest. At initial contact, basically the instantaneous center of rotation is in front and below the ground reaction force. So the knee is fully extended at this point and is inherently stable even if the user does have or create a hip flexion moment at this point. Loading the knee at heel contact will actually push the knee into extension, so that increases the safety at heel contact, providing a high level of safety, especially on uneven ground. During mid-stance, the instantaneous center of rotation is moving through the floor due to the design of the knee. And then the front and the rear bars of the knee move into a parallel position, so you can see that on the picture on the left here. As they move from the floor into a parallel position, the instantaneous center of rotation then moves to proximal and posterior, and this means the ground reaction force is still anterior to the knee at this point, maintaining stability until the toe is loaded and a hip flexion moment is initiated. Once the toe is loaded and a hip flexion moment has been initiated, the ground reaction force will then move posterior to the instantaneous center of rotation, and the knee will then flex and the user will be able to initiate swing phase. And think about it, that the level of safety that the closing geometry of the knee provides is actually comparable with the geometric lock that the total knee range provides. It's also worth noting that this safety element only works when there are no wedges used in the knee. The OHP3 comes with A and B wedges that can be screwed onto the anterior of the knee. The B wedge has the large angle to it, so if no wedges are fitted to the knee, then the closing geometry can be utilised for increased safety for the user. However, if you add wedge A, it can be fitted to create a more dynamic response if preferred, or if users are struggling to release the knee, then the wedge adjusts the geometry of the axis and creates an earlier stance release. The B wedge can also be fitted for more active users who prefer an even earlier stance release also. And you can just see from the picture at the bottom that it's simply just screwed onto the anterior of the knee. For the OHP3, we do have the stance release adjustments that I just discussed using the wedges. The pneumatics can also be adjusted to fine-tune it for the user, and this knee does feature high-pressure pneumatics, so it will allow the user to walk faster speeds of over 4 kilometers an hour. So that's just worth bearing in mind. And then again, the OHT3 comes with the option of the 4 proximal adapters, and the part numbers are up there on the screen. It has a maximum user weight of 125 kgs and a maximum flexion angle of 150 degrees. So introducing the OH5, the OH5 knee is a polycentric knee joint with closing geometry as well, and as well as a 3-phase hydraulic valve system for hydraulic swing phase control. So the closing geometry, which I've just discussed, provides increased safety during stance phase. However, this knee is aimed at a more active K3, K4 user who's capable of walking faster speeds of up to 10 kilometers an hour. It can also be combined nicely with the IKF adapter for stance flexion at heel strike to provide a more natural gait pattern and shock absorption for the user. The hydraulic cylinder in this knee and the OH7 as well, they're filled under vacuum, so there's no air present, and the unit can be stored lying down. That's just worth noting. So the valve adjustments on the OH5 knee are actually the same adjustments you would make with the Total Knee 2000 or 2100. Valve A controls flexion resistances at 60 to 150 degrees, and this can be adjusted to control excessive heel rise. The B valve controls 0 to 60 degrees, which controls initial flexion, assists in extension, and is critical in slow walking as well. And then the C valve provides adjustment to extension, allowing you to dampen terminal impact if necessary. So just worth noting as well, the hydraulic valve should never be closed completely, otherwise high pressure will build up and it can be damaging to the hydraulic unit. The OH5 knee has a knee flexion angle of 150 degrees and a weight rating of 125 kgs. And again, it comes with a choice of those 4 proximal adapters that you can see on the screen there. So the OH7 is basically a heavier duty version of the OH5. It's aimed at more active TF or through knee users at K3, K4 level, and is rated to 136 kgs. And it features the same closing geometry of the OH5, making it more stable for users. And then the OH7 actually utilises the most up-to-date hydraulic cylinder, accommodating to changes in walking speed well. And it's possible to close the valves to allow the user to walk fast or go into a run. It also has the option of the 4 proximal adapters, including pyramid adapter featured in the picture, allowing for rotation and shift also. And then this unit comes with the option of 1 wedge, which can be screwed into the anterior of the knee and used to alter the geometry to release into a stance quicker, making it more dynamic for users. So in terms of the adjustments, as I just mentioned, there's only 1 wedge that comes with this, and using it will disengage the closing geometry and allow for an earlier stance release. And then the 3-phase hydraulic valves are the same as the OH5 and the Total knees also. It's rated to a higher maximum user rate of 136 kgs in comparison to the OH5. And it also comes with a choice of the 4 proximal adapters, including the loop adapter for long transfemorals or through knee users. So now we've got to the passo. You might be able to see the video in the corner of the screen there. I wanted to take it out because I don't actually like horses, but I've left it in because basically the passo is named after a Peruvian breed of show horse, because it's known for its smooth ride and ability to take small, quick steps. So that's where the name comes from for this knee. And the knee's pretty exciting. It's something different for the market in that it features auto-adaptive pneumatic swing phase control, which requires no valve adjustment and can therefore be used straight out of the box. It's indicated for transfemoral or through knee users, and it's actually suitable for a wide range of users from K2 to K4 due to its high level of stability and stance from the closing geometry that it has, as well as its ability for varied cadence and faster paced walking for more active users. And the knee adapts incredibly well to changes in walking speed. It's also capable of smooth and powerful running. So with the passo we can guarantee speeds of up to 7 kilometers an hour. However, it can go as high as 12 for some users. This knee does have wedges that can be applied to adjust the geometry to make it more dynamic if required. And again, you can choose between the 4 proximal adapters, including the IKF adapter if stance flexion is preferred. So the Passo has A and B wedges, like the OHP3, which can be screwed into the front of the knee in order to adjust stance release. And other than that, there's no other adjustments that can be made, as the pneumatics are auto-adaptive. There's no valves to adjust. So I'll run through this video so you can see how it works. Hopefully it's working. The Passo, it consists of one large chamber with a piston and a smaller chamber at the bottom, which has a spring-loaded outlet and is capable of closing to create turbulence to allow varying resistances to flexion and extension. So when the user is walking at 2 kilometers an hour, the small outer chamber outlet remains open, and that allows air to flow out of the chamber. But at faster walking speeds of up to 7 kilometers an hour, this small extra outlet in the chamber actually closes, and this leads up to a build-up of high pressure and more turbulence within the chamber, and effectively dampens knee flexion, limiting heel rise, and actually helps promote extension by pushing the piston faster into extension to keep up with the user's faster gait speed. During knee extension, the air in the piston passes through the spring-loaded hole within the piston and goes down into the small chamber below. And at the same time, the spring-loaded fresh air inlet at the top closes, and faster walking lets more air pass through the spring into the piston, leading to a faster extension rate. And before the knee reaches full extension, there's actually a build-up of pressure above the piston, which prevents a hard bump at terminal impact. And as I said, the cylinder is therefore auto-adaptive. There's no requirements for any adjustments to the pneumatics. Hence we're saying it can almost be used straight out of the box. So I do have some more videos coming up. As I said, they might be lagging, in which case please check them out and download them when this goes up in the next week or so. With normal pneumatic knee, you would actually adjust resistances to flexion and extension to the user's preferred walking speed. So if you adjusted the knee for a fast walking speed, they would then maybe have trouble when they're walking very slowly. But with a Passo, the user is able to go from a very slow speed to a very fast speed of up to 7 kilometers an hour with the potential for 12, whilst maintaining symmetry. So with even heel rise and stride lengths to match the sound side, which has been demonstrated in this video here. And in this video you can see the user is walking at a very slow speed of 0.8 kilometers an hour. However, he's still able to swing through at a suitable rate to match his sound side, displaying even step lengths as well. So if we move on to the next video, this one shows that the user is walking from 3 kilometers an hour, and the speed on the treadmill is gradually being increased to 4.5 kilometers an hour, and the knee is adapting and keeping up with the change in walking speed. Heel rise is even, there's no terminal impact present, and most pneumatic knees are generally limited to speeds of around 4 kilometers an hour. Again, apologies if these are lagging. And in this video you can see that the speed has been increased and the user is building up to walking at around 7 kilometers an hour. People will actually start to jog at around 6.5 kilometers an hour. So this guy has gone from a slow walk at 0.8 kilometers an hour, and he actually finishes up at a speed of 6.8 kilometers an hour in these videos, without showing any signs of uneven heel rise or terminal impact. One of the benefits of pneumatic swing phase control over hydraulic swing is that they can actually provide a more energy efficient gait for the user, as long as they can keep up with the user's pace. So in this instance we have a knee which can cope with very slow to very fast paced walking, and it's actually also capable of running. So in this clip, it's actually going to show you a user who's able to run at 12 kilometers an hour on the treadmill, and then he is able to keep up with him. Looking at Anna's screen, I can see this is lagging quite badly. So do try and download it, so you can actually see the video. Hopefully you get the idea. So the passo is rated to 136 kgs. It has a maximum flexion angle of 150 degrees, and you can see the part numbers on the screen there for the 4 proximal connecting options. And that is the conclusion of today's webinar.